Hello students, how are you all? I am Gurmeet Singh. Welcome to CREATA classes and also welcome to Coordinate Geometry series for class 10 student. In this lecture, we will cover the NCERT example questions for section formula. The other lectures are given in the description, check it out. We use the power of visualization to make you understand the concept in much easier way. So without taking any further time, let's start this lecture and take down question number 1. Here it is. Find the coordinates of the point which divides the line segment joining the point 4, -3 and 8, 5 in the ratio 3:1 internally. So first of all, we will observe the question. In this question, we are having 2 points. The first point let's assume as point A, which is 4, -3, and let's assume the second point as point B, which is 8, 5. Let's join AB, it will form the line segment AB. One more point is also given, that is point C. We are assuming that as point C, it is on the line segment AB. One condition is given that the point C is dividing the line segment AB into the ratio of 3:1 internally. Don't be confused by this word internally. Internally means the ratio 3:1 is internally within the line segment AB. This portion is 3 and this portion is 1. 3:1. When it is externally, then the ratio became outside the line segment AB. But for this case, it is only 3:1 internally. So this is the observation from the question. Let's approach the question using the section formula. We are having 2 points, point A and point B, and point C is dividing the line segment AB into the ratio of 3:1. And we have to find the coordinate of point C. So we will use the section formula. For the section formula, the x1, y1 will be the coordinate A and x2, y2 will be the coordinate B. And m1 is to m2 or m1, m2, the ratio is 3:1. m1 is 3 and m2 is 1. Further, we have to find the coordinate of point C. So xy will be the coordinate of point C. So let's apply the distance formula. Firstly, we will take down the x coordinate only. Let's put the value for the x coordinate. We know x1, x2, m1, m2. On solving, we got x as 7. It means the x coordinate of point C is 7. Further, let's take down the y coordinate. We know y1, y2, m1, m2. Let's put the value. On solving, we got the value of y as 3. That is the y coordinate of point C. So we got the xy coordinate of point C as 7, 3. That is our answer. Let's move to example number 7. In what ratio does the point -4, 6 divide the line segment joining the point A -6, 10 and B 3, -8? Firstly, let's observe the question. In this question, 3 points are given. Firstly, let's take the point A and point B. Point A is -6, 10 and point B is 3, -8. Let's join the point A and B to form the line segment AB. On this line segment AB, we are having the third point, which is -4, 6. Let's give the name to this point as point C. This point C is basically dividing the line segment AB into certain ratio, and we have to calculate this ratio. This is very important question. These type of question, that is finding the ratios, generally come in the exam, and various alternative approaches are there to solve this question. You should know the fastest approach to solve the question in the exam. We will take down the 3 different approaches to solve this question. You should know all the approaches, but you will apply the second approach that I am going to tell you. Firstly, the first approach, that is application of the section formula. Here point A is x1, y1 and point B is x2, y2, and the coordinate of point C is given, that is x, y. So we know the coordinate of 3 points, x1, y1, x2, y2 and xy. Here m1 and m2 are missing. We can apply the section formula, that is, this is the section formula. And we already know the coordinate of point C, that is the point which is dividing the line segment into certain ratio. Here firstly take down the x coordinate. We know the value of x1, x2, xy. Let's put the value. So this is the equation that we form. Let's solve this equation. On rearranging m1, m2, on solving, we got 7m1 is equal to 2m2. Or we can also say m1 by m2 is equal to 2 by 7. That is m1 is to m2 is 2 is to 7. The ratio of m1 is to m2 is 2 is to 7. So we got the ratio as 2 is to 7. That is the answer of the question. We can also get the same answer if we have taken down the y coordinate. That is, if we have taken down the y coordinate, that is 6 is equal to minus 8m1 plus 10m2 upon m1 plus m2. Let's solve this equation. We will get the same result. That is m1 upon m2 is 2 by 7. That is the ratio. So this is the first approach. We can use the section formula and we can calculate the ratio of m1 upon m2. Let's take the second approach. In the second approach, we will assume the ratio as k is to 1. This is the fastest approach and you should know this. Basically, you should know all the approaches, but this approach you should apply in the exam. Let's assume the ratio as k is to 1. We are not assuming the ratio as m1 is to m2. We have converted m1 is to m2 as m1 upon m2 is to 1 and m1 upon m2 as k is to 1. Got it? We have assumed the ratio as k is to 1. This will be the fastest. So let's apply the section formula. We know all the input. Let's take down the x coordinate. On putting the value and solving, we got k as 2 by 7. That is k is to 1 is 2 by 7 is to 1. Let's multiply 7 on both sides. We got the ratio as 2 is to 7. Got it? The same answer we have got, the ratio as 2 is to 7. This is the fastest. We have assumed the ratio as k is to 1. One side we got as 1. So we do not have to solve the complete equation of m1 is to m2. So this is the second approach. You should know this also. Let's go to the third approach. Third approach does not involve the section formula. That involves the distance formula. We know the coordinate of point A, C and B. And once we know the coordinate, we can use the distance formula to find the distance between those coordinates. So we can find the distance AC using the distance formula. And we can also find the distance CB using the distance formula. We got AC and CB and we have to find the ratio of AC is to CB. So we can divide AC upon CB. We got the ratio as 2 is to 7. That is the same answer. This is slightly lengthy, not recommended, but you should know this too. Just apply the second approach of k is to 1. We will also take down some of the question in the exercise 7.2. There we will directly apply the ratio as k is to 1. Let's move to example number 8. Find the coordinates of the points of trisection, that is points dividing in 3 equal parts of the line segment joining the point A 2, -2 and B -7, 4. Firstly, let's observe the question. This question is using the word trisection. Trisection means dividing the line segment into 3 equal parts. How is it? For that, let's take the point A and the point B. Point A coordinate is given as 2, -2 and the coordinate of point B is given as -7, 4. Let's join the line segment AB. This line segment AB is divided into 3 equal parts. That is trisection. 3 equal parts. Tri is 3. Let's give the name to the 2 points which is dividing the line segment into 3 equal parts as P and Q. This point P and Q is dividing the line segment AB into 3 equal parts. So we know the coordinate of point A and also the coordinate of point B, and we have to find the coordinate of point P and Q. So this is the observation we got from question. Let's approach the question. Here, can we say the ratio of AP is to PQ is to QB will be equal to 1 is to 1 is to 1, as AP, PQ and QB are equal to each other. The trisection concept that we have just discussed. So we got the ratio as 1 is to 1 is to 1. Here we can also say the ratio of AP is to PB is 1 is to 2. How we can say so? AP is 1, and if we add PQ plus QB, it will be 2. So we get the ratio of AP is to PB as 1 is to 2. Got it? Similarly, can we say the ratio of AQ is to QB is 2 is to 1? Yes, we can say so. Here AQ is 1 plus 1, that is 2, and QB is only 1. So the ratio of AQ is to QB is 2 is to 1. By using the various combination of ratios, we can calculate the coordinate of P and Q using different ways. So let's approach the question. Firstly, let's find the coordinate of point P. For the time being, let's dissolve the point Q. Now we are having only 3 points, A, P and B. We know the coordinate of point A, that is x1, y1, and the coordinate of point B as x2, y2, and we have to find the coordinate of point P, that is x, y. We also know the ratio of AP is to PB, that is M1 is to M2 as 1 is to 2. Got it? So we know all the value. Let's use the section formula and let's find the x coordinate. Let's put the value. On solving, we got x as -1. Got it? Simple calculation. Further, let's find the y coordinate. Let's put the value. Let's solve it. We got y coordinate as 0. So we got x coordinate as -1, y coordinate as 0. That is the coordinate of point P is -1, 0. So we have got the coordinate of first point P. Let's find the coordinate of point Q. We are having two methods in which we can find the coordinate of point Q. We can dissolve the point P, that is we can take the ratio of AQ is to QB as 2 is to 1 and apply the same section formula the same way we have done for point P, but here the ratio will be 2 is to 1, slightly lengthy one, but we will use the alternate method in which we will only take the line segment PB. For the time being, we are dissolving AP, the line segment AP. We are only taking the line segment PB. Now, can we say the ratio of PQ is to QB is 1 is to 1? Yes, we can say so. PQ is equal to QB. So the ratio of PQ is to QB, that is M1 is to M2, will be 1 is to 1. We know the coordinate of point P that we have just calculated as -1, 0, and we also know the coordinate of point B, which is given as -7, 4. So x1, y1 is point P and x2, y2 is point B. We know M1 is to M2, that is 1 is to 1. We can apply the midpoint formula of the section formula, the midpoint section formula. Here we can easily find the coordinate of point Q. We are using specially this midpoint formula because the ratio is 1 is to 1. We can also use the ratio as 2 is to 1, but that will be slightly lengthy because the ratio is 2 is to 1. Here the ratio is 1 is to 1. It will be slightly fast to solve the question. And in the exam, the time is very important. So you should use the midpoint section formula. But we can use the normal section formula also. The answer will be same. So let's apply the midpoint section formula. We know x1 and x2. So let's go for x coordinate. That will be -1 -7 upon 2. That is -4. In the similar way, we can go for the y coordinate, 0 plus 4 upon 2, that will be 2. So we got the q coordinate as -4, 2. That is the answer. We got the coordinate P as well as we have got the coordinate Q. Got it? I am also telling you the alternate approaches because in the exam you should know all the approaches. If you got stuck in one approach, then you can go to the second approach. That may be slightly lengthy, but in the end you will got the same answer. So you should know all the approaches. Moving to question number 9. Find the ratio in which the y-axis divides the line segment joining the points 5, -6 and -1, -4. Also find the point of intersection. Firstly, let's observe the question. In this question, y-axis is given and 2 points are given on the either side of y-axis. The first point is 5, -6 and the second point is -1, -4. Let's give the name to both the point as A and B. Further, let's join the point A and B. We got the line segment AB. This line segment AB is crossing the y-axis. Let's give the intersection point as point C. In this question, we have to find the coordinate of this point C, that is x, y, and we also have to find the ratio in which the point C is dividing the line segment AB. That is the ratio of AC is to CB. One thing to be noted here is that if you observe all the points on the y-axis, its x coordinate will be 0. That is, x coordinate of all the point on y-axis is 0. For this point, we have assumed the coordinate of point C as x, y. Here x will be 0. So we can take the coordinate of point C as 0, y. Why? Because x is 0 on the y-axis. Got it? So this is the question. Let's approach the question. We have just understood that whenever we have to find the ratio, we will use the fundamental of k is to 1. That is, we will assume the ratio as k is to 1. So let's assume the ratio as k is to 1. Now we can simply use the section formula. We know coordinate A as x1, y1. We know the coordinate B as x2, y2. We know m1 as k and m2 as 1. We can directly apply the section formula. Let's go for the x coordinate. Here we know x is 0 because all the x coordinate on y-axis is 0. So let's apply the section formula for x coordinate. On solving, we got k as 5. So we got the ratio as k is to 1, which is 5 is to 1. That is the one part of the question. We got the ratio 5 is to 1 in which the point C is dividing the line segment AB. Further, we also have to find the coordinate of point C. So we can use the section formula to find the coordinate of point C. We already know our x coordinate is 0. We can just put the value in the x coordinate. We will get the x coordinate as 0. Just for cross checking, let's target the y coordinate. We know y1, y2. K is to 1. We have just calculated k as 5. Let's put the value. On solving, we got y coordinate as -13 upon 3. So we got the coordinate of point C as 0, -13 upon 3. That is the answer of the question. Got it? Let's move to the last question, question number 10, the example number 10. If the points A 6, 1, B 8, 2, C 9, 4 and D P, 3 are the vertices of a parallelogram taken in order, find the value of P. So let's observe the question. This question is talking about a parallelogram ABCD. All the 4 points are given. The coordinate D is having the value P, which is the missing value, and we have to find the value of P. The coordinate of point D is P, 3. All the other coordinates are given in the numeric. So let's approach the question. In this question, we will use the property of the parallelogram. Basically the property of diagonals of the parallelogram. In our geometry lecture, we have covered all about the parallelogram, in which we have seen that the diagonals of the parallelogram bisect each other. Let's understand what it means. Let's draw the diagonal AC and BD. These are the two diagonals. Let's assume these 2 points are crossing at point O. Here the diagonal AC and BD will bisect each other. It means that BO and OD will be equal to each other and AO and OC will be equal to each other. The point O will be at the midpoint of AC as well as BD. Got it? So using this property, we will solve this question. The point O is at the midpoint. It means that AO is to OC is 1 is to 1 and OD is to OB is also 1:1. So we can apply the section formula of midpoint. So we can calculate the point O using A and C and also B and D. After finding the point O using both the diagonals point, we will equate both the equations. Then we will get the point P. Let's see what I am talking about. Firstly, let's use the diagonal AC. Here point A is x1 y1 and point C is x2 y2 and the ratio is 1:1. We can find the point O. Let's give name to the point O as x comma y. Firstly, target the x. Let's put the value 6 plus 9 upon 2. We got x as 15 upon 2. Similarly, let's target the y coordinate. That will be 1 plus 4 upon 2, which is 5 upon 2. So we got the coordinate of point O as 15 upon 2, comma 5 upon 2. Let's again find the coordinate of point O using the diagonal BD. Here let's assume the point B as x1, y1 and coordinate of point D as x2, y2. Note that we are having P in the coordinate D that we have to find. We will use the same section formula, the midpoint one, because the ratio is again 1:1. Let's target the x coordinate, that will be 8 plus P upon 2, and the y coordinate, it will be 2 plus 3 upon 2, which is basically 5 upon 2. Got it? Using both the scenarios, that is AC and BD, we are getting the y coordinate as 5 upon 2. It means our approach is correct. We got the y coordinate of point O as 5 upon 2. Here let's equate the x coordinate. We will get the point P. That will be 15 upon 2 is equal to 8 plus P upon 2. On solving, we got P as 7. That is the answer, the missing point. Got it? We have used the properties of the parallelogram to solve this question. Generally in the mathematics, when we combine two different concepts, like here we have combined the concept of geometry, the parallelogram and the coordinate system, then the question becomes slightly tough. That's why you should know all the different concept of mathematics. Like here the parallelogram, if you want to brush up the concept, check out the link in the description. We have the lecture on the parallelogram and the different type of quadrilateral, just for the brush up if you want to do. So students, we have done with NCERT example questions related to section formula. Meet you in the next lecture in which we will cover exercise 7.2. Bye for now and have a great day. Bye bye.